All right, so we did some stuff today in binomial distribution class, so I thought I would do a few questions for you on a YouTube video just because we didn't get a chance to go through too many. So these are from the book, and you can look them up, and I thought I'd do a couple. So let's just go through them so we can use the calculator. I can look at the calculator side by side, all right? 5% of electric bulbs are defective at manufacturer. 6 bulbs are randomly tested, with each one being replaced before the next is chosen. Determine the probability that 2 are defective. So this is exactly 2. So when it's exactly, we want to use the binomial PDF function in a calculator, okay? So if we have this, we can go second function here, distribution, and you can scroll down to binomial PDF. Here we go. So that's the exact amount. So what you can do for method marks is put binomial PDF, something like this, PDF. Now I've has the D. The trials, in this case, we have 6 bulbs, okay? And then from there we have what's the probability, our success rate, right? We have to talk about success rate. Well, 5% are defective. So a successful light bulb is one that is defective, which sounds a little bit strange, but that's how it is. So this will be 0.05. And finally, we have the X value. Well, we want to search for 2 defective bulbs, right? So we have 2. So if we put that in here, we have 6 here, 0.0, oops, let's see, clear, 0.05, and then if we go down 1, we have our X value, which is 2, and we press enter. We press enter again, and there's our value for our 2 defective light bulbs. So normally we can rewrite this as we have binomially distributed with our n being 6 and our success factor being 0.05. So that's another key that we could do for our method marks. It's binomially distributed. Okay. So here we have in the end 3 significant figures, 0.01, 2, 3. So there's our answer. Okay. In the second piece, it looks like we have at least one is defective. So of course we have 0 defective, 1, 2, 3, 4, 5, 6. So if we look at all these, if we wanted to, we could technically use binomial PDF, and if it says at least 1, that means we want 1, 2, 3, 4, 5, 6. So if we wanted to, we could use binomial PDF and find out what it is for this one, this one, this one, this one, this one, this one, and add them all up. But that's a little bit time consuming. So what we want to switch to is Binomial Cdf. Now, the thing is Binomial Cdf starts at 0 and starts adding these up, right? So if you try to use Binomial Cdf with the value of 1, it's going to add 0 plus 1. It doesn't go from 1 to 6. So as I said in class today, what you need to do is you have to go 1 minus the probability at x is equal to 0. So that's going to take all these probabilities combined, subtract the 0, okay, and give us the rest of them. So our binomial Cdf, we want to find out the value of 0. Now you might ask, okay, well, we're adding only 0, so why don't we use binomial PDF just to use 0? We can do that. So if we use binomial Cdf and we start our value, so let's go to our calculator so we can look at this again. So distribution in this case. So Cdf, if we press enter, the number of trials in this case again is 6. We already know our success rate it's our probability of 0.05. And our value that we're looking for is 0 because we're going to go 1 minus that quantity after to get all the other values from 1 to 6. Okay, so let's just see what happens in our calculator. We have 6, 0.05, and our x value is 0. Okay, so if we enter that, what it's doing is it's adding up all the probabilities up to 0, which is only 1. So technically you might say, well, why don't I just use Binomial Pdf for 0? All right, let's just double check if that will work the exact same way. So I'm going to grab my Binomial Pdf. In this case, I'm just going to put 0. So if I do this, I should get the same number, shouldn't I? Ah, there we go. Perfect. And now to finish off the question, that gives me the probability of getting 0 defective light bulbs, but I want the complement of that, which is 1 through 6. So if I go 1, subtract this amount, and press enter, there's our probability of getting 1 to 6. Okay, so if our answer should be to 3 significant figures, 0.265. Okay, so the way you could do this is you could go 1 minus this Binomial Cdf on your test, and then you get your method mark, right, showing all the values. Okay, and then writing your answer down to 3 significant figures. Okay, so there's an example of using the 1 minus idea. Okay, if we check our solutions, we can see if that's the case. Where's our solutions here? So 0.305, good, and 0.265 looks good as well. All right. Let's try question 2 just to see if we can do one more, see if everything goes okay. All right. So if I move this down here, let's read this question. Record shows that 6% of the items assembled on a production line are faulty. So I think my success rate is going to be 0.06. And remember, it's not successful when an item is faulty. It's just what we're looking for. Okay. A random sample of 12 items is selected with replacement. So I know my n is equal to 12. Find the probability that none will be faulty. So what we're going to do is we're going to have a binomial distributed with 12, 0.06. And we have that. So if there's none faulty, that's 0 faulty, right? So what we could do is we could go binomial PDF, and we're going to have, if we go this, I can take my calculator and grab my binomial PDF, and I can insert my values here. So we have instead 12. I'm going to insert a value. So second function, insert 2. So there's my 12. And now if I go over, my percentage of success is 6. So I'm going to change this to 6. And in this case, we're going to find 0 faulty. So if I press enter, there we go. So if this is the case, we can fill in 12, 0.06, and our value of 0. And that gives us 3 significant figures, 4, 7, 6. All right. So that's question A. Question B, at most 1 faulty. So if that's the case, if we have a whole bunch in line looking at 0 faulty, 1 faulty, 2 faulty, 3, ... up to 12, if it says at most 1 faulty, that means that 0 can be faulty and 1 could be faulty. So we should add these two up starting from 0. So this is Binomial Cdf. Okay, because we want to accumulate the sums of these two together. Or you could use Binomial Pdf and find out what it is for 0 and what it is for 1. So if you look at this question, actually we've already found what the value is for 0. So to make it easier, if it was in a test, I would just grab this value here, okay? And I would change this value to 1, like so, and press enter. And now I would add that to my other value, which is the 0 value, okay? So this is just to save a little bit of time. Now if I add those two, I get this value. So what you could either do is use CDF and put 0.06, oops, sorry. We're going to put 12 because that's the number of trials. 0.06 and up to 1. Or on the test, you could go Binomial Pdf at the 0 point plus the Binomial Pdf of achieving 1 here. Okay, so we already know that 12 and 0.06 is going to be our other commas here, right? And that should give us the same value. So for part B, we get 0.840. Okay, so there's our probability. All right, so that's A and B. Now if we go down to C, I'll switch colors here. So C, let's see, at least 2 will be faulty. So that means that 0 could be faulty, 1 could be faulty, and 2 could be faulty. So once again, my calculator set up to add one more of these values. We already have 0 and 1 together, right? So how about I just add 2 onto this value right here? So I go to my calculator, I move up and I grab my PDF again. I press enter. And now I want to know the probability of having just 2 faulty. And that's what it is. And I'm going to add that to the probability of 0 and 1 being faulty, which is this value we got in the previous section. If we do that, we get 0.968. All right. So if that's the case, then we have 2 ways of writing this. You could either do the Binomial Pdf of the 0 plus the Binomial Pdf of one of them faulty plus the Binomial Pdf of 2 faulty. Okay, so that's one method of doing it right here. And then the second method, of course, is just going Binomial Cdf. And that would have, we want to go up to 2 with our 12, 0.06, comma. And of course, these are here and here. They're also right here in these values here between these commas, okay? So once again, 2 methods. You can see that if they wanted you to add up, say, from 0 to 10, you wouldn't want to do this Binomial Pdf 10 times. It would just take too much time, all right? So, but in this question, it actually helps us because it starts off with 0, then with 1, then with 2, so it was quite easy to use our calculator to figure this out, all right? Now, finally, our last one, which is less than 4 will be faulty. So what's the probability that less than 4 will, let's see, find the probability that less than 4 will be faulty. So that is from, actually, once again, quite simple. It's Binomial Cdf from 0 to 3, right? Because it says less than 4. We don't include 4. So I can put 3 here. I can put my 12 here because that's how many trials we have, and 0.06. Or once again, I can take my my PDF and add on the last one, which is, because we've already found 0, we've already found 1, we've already found 2, and now we just have to add 3 onto there, okay? But let's see what happens. We should get a higher number than 0.968, shouldn't we? Because we're going to add another probability of having 3 faulty on. All right, so let's just start using our CDF and see if that's true. So we go back to Binomial Cdf. I have 12 trials. This changes to 0.06. And the x value, well, we want to know 0, 1, 2, and 3. We want to add up all 3 probabilities. And if I press enter, I get 0.995 or 0.996 to 3 significant figures. So if we do this here, let's just check our answers. I'll square off my answers so we can see them. So we have this answer for one, this answer for the other. We have this answer here, and then we have this answer here. So if we go back to our solutions, we have for question B 0.46, 0.476, 0.840, which is good here, and 0.160 and 0.996. So 0.996 and 0.968. So I've read the question wrong. So here's an example of screwing this up here, which is probably good that I've done this so that you guys can learn as well. It says at least 2 faulty. So I read this wrong. So we need 2 or more. So this is not how we do it. Let's take a look and fix this. So it's a good idea that I messed this up here. So if we want at least 2, right, that means 0, 1, 2, 3, ... up to 12. We need 2, 3, 4, and added all these ones up to 12, the probabilities of these working together here. So the easiest thing to do is go 1 minus the probabilities at 0 and 1, okay? And the good thing is that we already have 0 and 1 in the previous question, right? In part B, we needed to know 0 and 1. So I should just go 1 minus this 0.840 number. So on your calculator, make sure you go up and take the whole number so you don't mess this up. So here's the whole number. I press enter, and this gives me, so this is on your test, you can write this 840 ... so they know you have it rounded, and our value is 0.1 if I kick that up, 60. So now let's look at our solution. Is that correct? There we go. That makes sense. So making sure we read these values: none, at least, at most, less than. This is what I put in the notes, so you guys have to know that. All right, so I hope the video helps, and that the mistake I made will help you learn to make sure you don't do that mistake as well.